Hey everyone, and welcome. Today, we're going to dive into something that is absolutely foundational for building modern, clean apps, the MVVM architectural pattern. We're going to see exactly how to take that tangled mess of code on the left and turn it into the clean, organized, and beautiful architecture you see on the right.
So let me start with a question, and you got to be honest with yourself. Have you ever looked at your code and had absolutely no idea where your UI logic stops and your data logic actually begins? Yeah? If you ever tried to, fix a simple display bug and somehow you broke the data calculation, you know exactly the pain I'm talking about.
Well, that tangled mess, it actually has a name. We call it code spaghetti. And it's what happens when everything just gets thrown together in one place. Your UI code is fetching data directly, your business rules are all over your UI files, and it becomes a total nightmare to test, to debug, or even just to understand what you wrote 6 months ago. And when you put the two approaches side by side like this, wow, the difference is just night and day. Without a clear architecture, your code is nearly impossible to test, it's incredibly fragile, and it loses its state when you do something as simple as rotate the screen. But with MVVM, the whole game changes. Your code becomes easily testable, truly maintainable, and it handles state like an absolute champ. So how do we get from that chaotic, brittle code to something that's robust and, a joy to work with? Well, that brings us to our solution for today, MVVM. It's a really elegant pattern that was designed to solve this exact problem of tangled logic. At its very heart, MVVM, which stands for Model-View-ViewModel, is all about one thing: creating a clean separation between your business logic and your UI logic. It's about drawing a line in the sand, creating clear boundaries that just make your entire app so much easier to think about and to manage. To really get how it works, we need to break MVVM down into its three fundamental components. I like to call them its three core pillars. That's right, just three parts. And once you understand the specific job that each one of these parts has, the entire pattern just clicks into place. It's way, way simpler than it might seem at first. And this is maybe the best way to think about it. Imagine a restaurant. The model, that's your data. It's just the raw ingredients sitting in the pantry: flour, eggs, sugar. Then you have the view. That's the final, beautifully plated dish that gets served to the customer. It only cares about how things look. And then, the most important part, the view model. That's the chef. The chef has the recipe, the logic, and uses the ingredients from the pantry to cook the dish. But the chef never actually talks to the customer. That's the crucial part. The view model is the logic middleman. Okay, theory is great and all, but let's make this real. We're going to walk through a super simple counter app to see exactly how these three pillars work together in Kotlin. First up, the model. In our case, it's about as simple as it gets. It's just a Kotlin data class called counterState. Its only job, its entire purpose in life, is to define what our data looks like. Here, it just holds a single number, the count. That's it. No logic, no funny business, just the state. Next up, we've got the chef, our counter view model. Now this is the brains of the operation. It holds on to the current state and it exposes functions like increment counter that contain the logic to change that state. The key thing to realize here is that the view model has zero idea what the UI looks like. It doesn't know about buttons or text or colors. It just manages state and logic, period. And if we look a little closer, we see this really important pattern inside the view model. There are two state variables. The first one, _UI state, is private and mutable. That means only the view model itself is allowed to change it. Then it exposes a public, read-only version for the UI to look at. And this is the genius of the pattern. It makes it literally impossible for the UI to accidentally mess with the state directly. And finally, we have the view. In Jetpack Compose, this is our counter screen. And notice it has two very simple jobs. First, it observes or collects the state from the view model, so it's always listening for changes. Second, when the button gets clicked, it doesn't try to change the count itself. No. It just tells the view model, hey, the user tapped the button, and it calls that increment counter function. And this right here is the magic of modern reactive UI. The view just listens. So when the view model updates the state, the UI, which is listening to that state, sees the change and automatically redraws itself to show the new count. You don't have to manually update anything. It just works. So we've seen the how, but let's circle all the way back to the why. Why do we even go through the trouble of separating everything out like this? What are the actual real-world benefits?
It really all comes down to these three massive wins. Maintainability, you can throw away your entire UI and redesign it from scratch without ever touching your view model logic. Testability, you can write super simple unit tests for all your logic right on your computer without ever even opening an emulator. And state management, because the state lives safely in the view model, it survives things like screen rotations that would normally wipe out all your data. And these aren't just nice to haves. On a big app, this separation is what keeps the project from collapsing under its own weight. So, you want to try this out? Getting started is actually pretty simple. First, you just add the one dependency to your project. Second, and this is my pro tip, write your view model and its logic first, even before you think about UI. And finally, you build your UI and just connect it or bind it to the view model you already created. And there you have it, the fundamentals of MVVM. You now have the blueprint to go out and create apps that are clean, they're testable, and they're robust. Of course, the next step is getting data from a real source, right? Not just from inside the view model. So the question is, are you ready to add a repository for fetching that data?